Hello everyone, I am Dr. VRAO. In the lecture 67 of thermodynamics, we discussed, we learned that spontaneity or irreversibility of a process based on Gibbs free energy change. I repeat, in the lecture 67 of thermodynamics, we discussed spontaneity or irreversibility of a process based on the Gibbs free energy change. And I also told you that irreversibility or spontaneity of a process, we can say that spontaneity or irreversibility of a process based on other thermodynamic functions also. Other thermodynamic functions are internal energy, entropy, enthalpy, Helmholtz work function. Therefore, we can say the spontaneity or irreversibility of a process based on other than Gibbs free energy thermodynamic functions, other than Gibbs free energy, that is entropy, enthalpy, Helmholtz work function and internal energy, right? So, in this lecture, let us try to say the spontaneity or irreversibility of a process based on these thermodynamic functions, right? So, let us derive the what is it called, mathematical formulation, right? Okay. So, we know that from the second law of thermodynamics, we know that that is ds is equal to q reversible by t. Okay, this is the mathematical formulation of second law of thermodynamics. Okay, from this we can write T delta S is equal to Q reversible, right? T delta is equal to Q reversible. And from first law of thermodynamics, this Q reversible is equal to du plus PdV. From the first law of thermodynamics, we can write Q reversible is equal to du plus PdV, right? Therefore, TDS is equal to du plus PdV, right? These two terms, that is TDS, TDS is a measure of unavailable energy, as ds or entropy change or entropy is a measure of unavailable energy. When it is multiplied with the temperature, this term also is a measure of unavailable energy, right? These two terms are equal for reversible process, right? You should keep this point in your mind. These two terms, that is TDS is equal to du plus PdV for reversible processes, right? For reversible process, right? And TDS is greater than du plus PdV for irreversible processes, right? So, you should keep this point in your mind. TDS is equal to du plus PdV in case of reversible processes, right? Reversible processes is nothing but non-spontaneous, right? And TDS is greater than du plus PdV, that is TDS term is greater than du plus PdV for irreversible processes. Irreversible process is nothing but spontaneous process. Therefore, by combining these two equations in one equation, that is TDS is greater than or equal to du plus PdV. du plus PdV. Okay, this is the fundamental equation. This is the fundamental equation by which we can say the spontaneity of a process based on any thermodynamic function, based on any thermodynamic function. Okay, I repeat, this is the fundamental equation based by which we can say the spontaneity or irreversibility of a process based on any thermodynamic function, that is entropy, enthalpy, Gibbs free energy, Helmholtz work function. Already we discussed the spontaneity or irreversibility based on Gibbs free energy in the last class, right? In this class we are we shall try to say the spontaneity or irreversibility of a process based on entropy, internal energy, Helmholtz work function, right? Internal energy, right? Okay, so this is the fundamental equation, right? This is the fundamental equation. Now let us try to say the spontaneity or irreversibility based on internal energy or based on entropy or based on Helmholtz work function. Okay, now at first I shall try to define the spontaneity based on entropy, right? Entropy, right? Okay, so now let us try to say the spontaneity in terms of entropy, in terms of entropy. So, okay, in terms of entropy. Okay, actually we are trying to say the spontaneity based on entropy. So when we are trying to say the spontaneity based on entropy, okay, take this equation, see this equation. We are trying to say the spontaneity based on entropy. So we need to keep the constant of keep the internal energy and volume. We need to what is it called, du plus du and dv. We need to make the make these two terms constant, right? That is u, that is internal energy, is constant. We need to kept these two quantities, kept these two constants we need to kept these two terms at constant, right? U is equal to constant and v is equal to constant. When u is constant, then its derivative du is equal to 0. When v is constant, its derivative dv is equal to 0. Okay, so for isothermal process, T also remains constant. For isothermal process, T remains constant. So in this process, T is also constant, right? So du is 0 and dv is 0 and the whole term is becomes 0. The whole term, and T is remains constant. Okay, therefore this equation takes the form ds greater than or equal to 0. ds is greater than or equal to 0. Okay, so already I told you equal to symbol is for reversible process and greater than symbol is for irreversible process. Okay, so we can write ds, it is at constant internal energy and constant volume is greater than or equal to 0. Which means that now we can say the spontaneity based on entropy change, that is ds values. Okay, so ds, when ds at a constant u and v equal to 0, that is equilibrium process, that is equilibrium process. Okay, and if ds at a constant u and v is greater than 0, if it is greater than 0, greater than symbol is for irreversible process. If ds is greater than 0, that is irreversible process, that is spontaneous. Irreversible is nothing but spontaneous. right? Okay. And coming to the what happens if ds at a constant internal energy and constant volume is less than 0, then that process is reversible. Then that process is a reversible process, that is non-spontaneous, right? Okay. So, in this way we can say the spontaneity of a process based on entropy. So, ds is greater than 0 if for in a particular, or for example, if we try to say the whether that process, whether the given process is spontaneous or non-spontaneous. If that for the given process, if ds is greater than 0, then that is irreversible process. If that given process for the given process, if ds is less than 0, that is reversible or non-spontaneous. And let us see the spontaneity in terms of internal energy. Now, in terms of internal energy, okay. So, again take this equation, we are trying to say the spontaneity based on internal energy. So, we need to maintain ds and dv or constant, that is entropy and volume to be constant, right? So, for its entropy constant, we need to keep these two quantities constant, then ds equal to 0 and dv equal to 0, okay. And ds and dv equal to 0, then this and for isothermal process, this is also isothermal process, and ds equal to 0, from this ds equal to 0, therefore this equation takes the form 0 greater than or equal to, okay, already dv is 0, so this entire term becomes 0, therefore du, okay. So, for the sake of my convenience, I change this equation into du less than or equal to 0, okay. Just I invert this equation, okay. 0 is greater than or equal to du, okay. Du is less than or equal to 0, both are same, right, okay. So, now define the spontaneity. Du at a constant entropy and constant volume less than or equal to 0, okay. Already I told you that means du at a constant s and v equal to 0, that is equilibrium process, okay. If du at constant v less than 0, already I told you this symbol is for irreversible process, but this symbol takes the another form, that is less than symbol for during the mathematical calculation, right, during the mathematical treatment, that symbol changes into less than, okay. So, if less than 0, that is irreversible process or spontaneous process. If ds du at constant v greater than 0, that is a reversible process, that is non-spontaneous process, okay. Now, let us try to say the spontaneity in terms of Helmholtz work function, okay. Before going to going to say the spontaneity based on Helmholtz work function, first we shall try to say the spontaneity based on enthalpy. So, by understanding the enthalpy calculation, we can easily understand the Helmholtz work function. That is why I am deriving in terms of enthalpy, okay. I am deriving spontaneity in terms of enthalpy, okay. Enthalpy, by the definition, enthalpy is equal to H is equal to E plus PV, E plus PV. Okay, on differentiation dH is equal to that is dH is equal to E plus PV or U plus PV, internal energy. This is the sign notation. We can denote internal energy with either E or U, right? So on differentiation, this is du plus this is in the form of UV formula, UV dash VU dash, that is PdV plus VdP, PdV plus VdP. Okay, and the basic equation is TDS. Okay, TDS is greater than or equal to du plus PdV. This is the basic equation. So for the sake of my convenience, I need to take this VdP into onto this in this side, to this side, sorry. dH minus VdP is equal to du plus PdV, du plus PdV. Therefore, we can write dH minus VdP instead of du plus PdV in the basic equation, right? So, from the basic equation, TDS is greater than or equal to du plus PdV. du plus PdV in terms of instead of du plus PdV, we can write dH minus VdP. Okay, so dH minus VdP, right? And now from this, this is the equation. Okay, now we are trying to say the spontaneity in terms of enthalpy. So we need to keep these two are constant, that is entropy and pressure are constant, right? So at entropy constant, then ds equal to 0. If pressure constant, then dP equal to 0. Okay, right. So therefore this term becomes 0 greater than or equal to dH because dP is 0. So this term becomes 0. Okay, for the sake of my convenience, 0 is greater than or equal to dH, or dH is less than equal to 0. Okay, these two are same, both are same, 0 greater than or equal to dH, or dH is less than or equal to 0. Okay, now we can write dH, right, dH at a constant entropy and at constant pressure less than or equal to 0. From this we can say the spontaneity. For example, if dH at a constant entropy pressure is equal to 0, this is a equilibrium process, right? If dH at a constant entropy and pressure less than 0, that is a irreversible process, right? If dH at a constant entropy and pressure greater than 0, that is a reversible process, Okay, in this way we can say the spontaneity based on enthalpy, right? Now we shall try to say the spontaneity based on Helmholtz work function. Okay, by definition, Helmholtz work function is defined as a Helmholtz work function. Now, in terms of Helmholtz work function, A, in terms of A, Helmholtz work function. By definition, Helmholtz work function is defined as A is equal to U plus PV, or A is equal to E plus PV. A is equal to E minus TS, A is equal to U minus TS or E minus TS, right? So on differentiation, dA is equal to du minus, it is in the form of UV formula, applying UV formula, TDS minus S dt, right? For the sake of my convenience, I am taking the TDS term and SDT term onto this side. dA plus TDS plus SDT is equal to du. Okay. So that we can substitute this value in the basic equation, right? Right. So, from the basic equation, TDS is greater than du. Instead of du, we can write dA plus TDS plus SDT plus PdV, right? This TDS and TDS get cancelled, okay, and therefore 0 greater than dA plus SDT plus PdV, okay. Now we are trying to say the spontaneity based on Helmholtz work function. So, we need to keep these two are constant, that is temperature and volume to constant, right. So, that is at a T constant, then dt is equal to 0, its derivative equal to 0. When volume constant, its derivative dV is equal to 0. Okay. Therefore, 0 greater than or equal to dA. Okay, because dt is equal to 0 and dV equal to 0. Okay. Therefore, for the sake of my convenience, I change this equation, because 0 is greater than or equal to dA or dA less than or equal to 0. Both are same. Okay. Both are same. Okay. So, therefore, we can write dA at a constant temperature volume is less than or equal to 0, from which we can define the spontaneity, that is dA at a constant temperature and volume is equal to 0. If it is 0, then it is equilibrium process, right. If dA at a constant volume less than 0, then it is a irreversible process. This irreversible process is nothing but spontaneous, right. And if dA at a constant temperature and volume greater than 0, then it is a reversible process. Reversible process is nothing but spontaneous, right. Spontaneous. Okay. So, in this way we can say the spontaneity of a given process based on internal energy, entropy, enthalpy, Helmholtz work function. Okay. From the last class up to last class, we know that we can say the spontaneity based on Gibbs free energy, but we can say the spontaneity based on other than Gibbs free energy, that is enthalpy, entropy, Helmholtz work function and internal energy. Okay. I hope you learned something, and if you really learned something, please extend your support by like, share, comment and subscribe. Thank you.